would you die on every planet in the solar system? What happens if an astronaut takes off their suit on the moon? The moon is a hostile and unforgiving environment for any living being. Its lack of atmosphere and pressure turns any exposure without a spacesuit into an experience that would lead to a painful and inevitable death. If an astronaut decided to remove the suit on the lunar surface or their suit were to rupture, the absence of pressure would cause the gases in the blood and lungs to expand uncontrollably, causing explosive decompression, i.e., the astronaut's body would implode. Body fluids such as saliva and water from tears in the eyes would begin to boil due to the low pressure of the lunar vacuum, a phenomenon known as decompression boiling. This would cause the astronaut to start getting steam from his mouth and eyes. It would be an impressive sight to see. However, the blood inside the veins would not evaporate instantly thanks to the internal pressure of the blood vessels. Although initially acting as a barrier, the skin could not contain the expansion of internal gases and would begin to swell as if it were being inflated with an air pump. As if this were not enough, extreme temperatures could create two scenarios depending on the astronaut's location. If the astronaut is in the shadow, i.e., not under the sun's rays, the temperature will be about -274 degrees Fahrenheit, -170 degrees Celsius. This could freeze the exposed tissues until they become a human ice statue. The second scenario involves the astronaut being in direct sunlight. In this case, the temperature could be up to 248 degrees Fahrenheit, up to 120 degrees Celsius, which would scorch the astronaut. Solar radiation breaks down the molecules in the skin and tissues, and after many years, this turns into dust. After bodily fluids such as saliva and tears evaporate, blood will also begin to evaporate just 10 seconds later. And in the 15th second, the astronaut would lose consciousness due to lack of oxygen, and in less than 2 minutes, he would have died. Suppose death occurs under the sun rays, such as in the Mare Tranquillitatis, where the first astronauts landed. Solar radiation would destroy skin molecules and tissues. Still, if death occurs in the shadows, such as inside a crater at the South Pole, the astronaut's body could be preserved frozen for eternity. Which death would be the most painful, under the sun's rays or in the shade? Please leave us your opinion in the comments. As we can see, the moon is not a very friendly environment with humans, even though it is the only world besides Earth where humans have been. Something similar happens on the solar system's planets, from Mercury to Neptune. No planet would treat us with the same hospitality that Earth treats us. To visit any planet in the solar system, we need spaceships and spacesuits. If any of these breaks down or ruptures, we will inevitably die. But how would we die? Would it be the same as dying on the moon or much worse? On what planet would we have the least painful death? Keep watching to find out. Mercury. Let's start with Mercury, the planet closest to the Sun. This planet is inhospitable to any known life form. Its near-zero atmosphere, extreme temperatures, and intense solar radiation make its surface one of the deadliest environments in the solar system. If our spacesuit were to fail or somehow break while on Mercury, it would be an instant death sentence and an excruciating and fascinating process from a scientific perspective. Mercury does not have an atmosphere as large as Earth's. Instead, it has an exosphere of traces of hydrogen, helium, oxygen, and other elements. Because of this, the main form of heat transfer is radiation. So, just like on the moon, Mercury's temperature depends on whether it is exposed to the sun's rays. If you're in the sun's rays, the temperature can reach 806 degrees Fahrenheit or 430 degrees Celsius during the day. While, if you're in the shade on the side of the planet where it's nighttime, temperatures could drop to -292 degrees Fahrenheit or -180 degrees Celsius. In addition, due to its proximity to the Sun and the absence of a protective magnetic field, the solar radiation on its surface is approximately 10 times greater than the Earth receives. Considering all this, suppose an astronaut stands on the surface of Mercury and a micrometeorite pierces his spacesuit. Second 0. At the moment of the breakage of the spacesuit, the astronaut would be immediately exposed to the almost absolute vacuum of space. There is no air to breathe, so the oxygen supply to the brain would be instantly interrupted. 5 seconds after the suit ruptures, the astronaut begins to experience severe hypoxia, lack of oxygen. The unprotected lungs collapse, and the residual air can escape explosively due to the change in pressure. This causes a swelling in the chest that feels like a massive bubble of air. Just like on the Moon, due to the absence of atmospheric pressure, the body's fluids, saliva, tears, water in the tissues, would begin to boil by decompression. This does not imply intense heat, but rather that liquids would quickly become gaseous, released as vapor. At the 10th second, the lack of oxygen causes a loss of consciousness. Meanwhile, the blood in the veins and arteries, although it does not boil immediately due to the vessel's internal pressure, is subjected to extreme stresses, causing indescribable pain. At the 20th second, if the astronaut were still on the illuminated face of Mercury, he would begin to suffer severe burns from direct solar radiation. Solar energy would be enough to damage exposed tissues in seconds and break down skin molecules. At 30 seconds, if the astronaut is still conscious, skin and tissue will begin to char under the sun's rays at temperatures of 806 degrees Fahrenheit or 430 degrees Celsius. On the other hand, if the astronaut were in the shadow, any body part would experience extreme cooling due to the skin and tissues being at minus 292 degrees Fahrenheit or minus 180 degrees Celsius, causing instant frostbite. In the 60th second, the damage would be irreparable. The internal organs would have stopped, the tissues would have started to tear due to the lack of pressure, and the radiation exposure would have destroyed the DNA. The only consolation is that if you die on Mercury, you will be able to have one of the most breathtaking views of the Sun. Now, we know the terrifying death awaits us if our spacesuit breaks on Mercury. Would this be the worst death of all? Maybe not, because there is a planet that is the closest thing to hell. Venus. Venus, known as Earth's hell twin, is one of the most extreme planets in the solar system. With scorching temperatures, crushing pressures, and a corrosive atmosphere that could melt any spacecraft, it would have no mercy on an astronaut standing on its surface. Venus's surface is a furnace at 887 degrees Fahrenheit or 475 degrees Celsius, hotter than the temperature needed to melt lead. The atmosphere, composed mainly of carbon dioxide, 96.5%, and traces of sulfuric acid, has a pressure of about 92 times the atmospheric pressure of the Earth. This is equivalent to being submerged under 1 kilometer of water. In addition, although the thick atmosphere attenuates some solar radiation, the level of radiation is higher than on Earth due to the lack of a protective magnetic field and the proximity to the Sun. An astronaut in this hostile environment must wear state-of-the-art suits capable of withstanding anything, including high temperatures, high atmospheric pressure, and an atmosphere full of corrosive gases. But if the unfortunate astronaut had an accident that damaged the suit, either by cracking or breaking it, it would be the end of him. The first second after the suit broke, the astronaut's body would instantly be exposed to Venus's atmosphere. The human body cannot withstand these extreme forces, which would result in almost immediate death by crushing. The pressure of 92 atmospheres would be enough to collapse the chest and internal organs. The gases contained in the lungs and bloodstream would be violently compressed, causing the body to implode and its organs to shoot out as if a bomb had been placed in its stomach. The good news is that this would be a quick and painless death. The bad news is that it would be a horrible thing to watch. If the rupture is a few millimeters and the suit has a system to regulate the pressure, it could continue to be pressurized and help the astronaut survive until he re-enters the spacecraft. However, this did not prevent burns from corrosive gases outside. 2 seconds after the suit ruptured, the atmosphere, rich in carbon dioxide and sulfuric acid, would begin to melt the skin and eyes, causing devastating and excruciating chemical burns. If the astronaut is still alive after feeling his eyes melt, in the 5th second after the suit breaks up, the flesh will begin to char rapidly due to the outside temperature of 887 degrees Fahrenheit or 475 degrees Celsius. The sweat and surface fluids boil instantly, while the soft tissues cook in seconds. At this point, any human would be completely dead. However, if for some reason the astronaut is still alive, his skin would cook to 887 degrees Fahrenheit. 10 seconds after the suit breaks, the intense pressure would cause the body to collapse and break into pieces. Denser bones and tissue will hold up a little longer, but not for long. At this point, the astronaut is no longer with us. 30 seconds after exposure, because the body is still subjected to extreme temperatures, the remains would char and fragment. Venus's toxic atmosphere would prevent any possibility of preservation. On the surface of Venus, an astronaut without a spacesuit would die in less than 10 seconds, mainly due to crushing pressure and scorching heat. This extreme environment, with its high temperatures, toxic and corrosive atmosphere, and constant radiation, makes it an actual hell where human survival without technology is impossible. Could there be a worse way to die? Hey, before moving on, be sure to like or dislike the video so that we can improve them for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Mars. While Mars is not a place where we can walk without a spacesuit to protect us, at least we wouldn't die in ways as horrific as those we've observed on Mercury and Venus. Although Mars is one of the most explored and fascinating destinations for humans, it is still a lethal environment. The Martian atmosphere is 100 times less dense than Earth's and is almost entirely composed of carbon dioxide, 95%. The average pressure is only 6 millibars, which is insufficient to hold bodily fluids. Temperatures range from 68 degrees Fahrenheit or 20 degrees Celsius during the day to minus 193 degrees Fahrenheit or minus 125 degrees Celsius at night, while solar and cosmic radiation levels are significantly higher due to the lack of a magnetic field and protective atmosphere. Although daytime temperatures on Earth are very similar, we must remember that the atmosphere on Mars contains almost no oxygen. If an astronaut suffered a break or breakdown of his suit, they would first notice a lack of oxygen. To do this, I could hold my breath, right? Unfortunately not. The moment the suit breaks, the astronaut faces low Martian pressure. If he were to try to hold his breath, the air in his lungs would expand violently, causing a fatal rupture of lung tissues and causing instant death. In this case, the best thing you could do is not breathe. Just as on the Moon and Mercury, without sufficient atmospheric pressure, 5 seconds after the suit ruptures, the surface fluids of the body, such as saliva, tears, and mucous membrane fluids, begin to boil by decompression. The blood inside the vessels, protected by internal pressure, would not boil immediately. Instead, it would be subjected to extreme stresses that would cause unimaginable pain. Fortunately, all this pain and suffering would not last long because in the 10th second after the rupture of the suit, the lack of oxygen would cause cerebral hypoxia, causing disorientation and loss of consciousness. At this point, the astronaut would still be alive, but would be completely unconscious, unable to feel what was happening. In the 20th second, the external tissues would begin to freeze, especially in the extremities and areas exposed to the Martian atmosphere. 3 to 5 minutes after the suit ruptures, lack of oxygen and boiling and freezing damage would lead to complete systemic failure. the internal organs would collapse and the astronaut would leave this world. A relatively painful death if we compare it to Venus, right? Mars may look similar to Earth in some ways, but its conditions remind us that humanity cannot migrate to it for now, despite being the most explored planet. The asteroid belt and Ceres. Before reaching the next planet, our space adventurer must pass through an area packed with huge rocks, the asteroid belt. Contrary to popular belief, although the asteroid belt truly has millions of tiny bodies floating everywhere, space is so immense that each asteroid is separated by several million kilometers. Hence, the chances of accidentally colliding with one are extremely low. However, there is one body that we could visit out of curiosity: Ceres, the dwarf planet located within the asteroid belt. This minor body is much smaller than a planet and even smaller than Earth's moon, but it has its charm. It is the closest dwarf planet to Earth. If an astronaut wanted to visit Ceres, he would find an environment similar to our moon's. The vast difference is that the temperature on Ceres would be much lower and gravity would be weaker, so he could make 5-meter jumps without any problem. However, Ceres hides one of the strangest structures in the solar system: ice volcanoes. These volcanoes can eject large amounts of ice to the surface. If an astronaut were too close to one just as an eruption occurs, they would be trapped, buried under a massive layer of nitrogen ice and eternally frozen. So, if you decide to visit this tiny, icy world before reaching Jupiter, beware of cryovolcanoes. Jupiter. From here on, we will visit gas giants. We can no longer imagine any scenario in which an astronaut stands on the surface of one of these, as gas planets do not have a solid surface like Earth's. Instead, they have layer after layer of gases with different densities that make up the atmosphere. Jupiter is the largest planet. It is composed mainly of molecular hydrogen, 90%, and helium, 10%, with traces of methane, ammonia, and water. As you might expect, an astronaut must visit this planet in a spacecraft capable of withstanding winds, cloud pressure, and high temperatures. Although temperatures in Jupiter's upper layers range from minus 229 degrees Fahrenheit or minus 145 degrees Celsius to 43,232 degrees Fahrenheit or 24,000 degrees Celsius in the deep interior, an astronaut would most likely not be able to penetrate that deep into Jupiter's clouds. He may not even reach the upper clouds. Why? This is due to the intense radiation. Like Earth, Jupiter is surrounded by a radiation belt. However, Jupiter's radiation belts are 20,000 times more intense than Earth's. These invisible radiation belts are so big that many of Jupiter's moons lie within them. Not only are they massive, but they are also very dangerous. The radiation from Jupiter's belts is caused by a collection of charged particles such as protons, electrons, and ions, millions of times more than the human body can withstand. An astronaut heading to explore Jupiter would first have to pass through these intense rings of radiation. This would cause internal burns and DNA damage almost instantaneously. The damage from the intense radiation at first would be painless. The astronaut would not notice anything strange in his body, but a few minutes later he would begin to feel nauseous due to the massive destruction of cells in the gastrointestinal tract. You would notice a noticeable loss of strength as the body tries to repair the damage the radiation is causing. 10 minutes later, when it is still thousands of kilometers away from reaching Jupiter's atmosphere, the radiation would directly affect the brain and nervous system, causing confusion, seizures, intense dizziness, and vomiting. 1 hour later, with several hundred kilometers still to go before touching the first clouds of Jupiter, tissues exposed to massive doses of radiation would experience necrosis and systemic failures, like internal burns that would cause intense pain, accompanied by massive damage to vital organs such as the bone marrow, heart, liver, and lungs. The blood vessels would be destroyed entirely, leading to internal bleeding that would cause the astronaut to vomit his organs and cause bleeding from the eyes and ears. When the spacecraft came to touch Jupiter's first clouds, radiation damage would have ended the astronaut's life on board. Dying before you even entered the planet is an anticlimactic end if you think about it. Unfortunately, even though we could equip spaceships with mini magnetic fields to protect them from radiation, there is still no realistic way to avoid it 100%. That is why, even though Jupiter has high-speed winds, toxic gases like methane and ammonia, extreme temperatures and pressures that would crush our bodies, none of it matters. If we cannot avoid radiation, we will die long before we even hit the first clouds. Saturn. Saturn, the ring giant, is a fascinating but deadly world. Its atmosphere, composed mainly of hydrogen and helium, lacks oxygen and is full of colossal storms, extreme temperatures, and crushing pressures. If an astronaut were aboard a spacecraft descending uncontrollably into its atmosphere, the outcome would inevitably be fatal. However, as with Jupiter, the greatest danger may lie outside the planet. Saturn's biggest draw is its rings. The rings are composed of almost pure ice, which gives them their shiny, reflective appearance, which is majestic and impressive. The particles in the rings are of various sizes, from tiny microscopic grains to blocks several meters in diameter. Interestingly, these rings orbit Saturn at several tens of kilometers per second. In the E-ring, particles travel at speeds between 4 and 1 mile per second, or 7 and 3 kilometers per second. But in the D-ring, the closest to Saturn, particles travel at more than 16 miles per second, or 26 kilometers per second, or 58,160 miles per hour. That's 93,600 kilometers per hour. This is almost 75 times faster than the speed of sound on Earth. At this speed, an impact with any of these particles would be fatal to any spacecraft. In fact, in the past, different spacecraft such as the famous Voyager probes or the Cassini spacecraft had problems with these rings that forced them to recalculate their trajectories. If one of these particles were to impact the human-crewed spacecraft where our beloved astronaut is located, it would be the end. If he managed to dodge the small particles, he would still have to plan his trajectory very well so as to not collide with the dozens of moons that orbit Saturn. It would be quite an adventure, but if you manage to evade all these obstacles, you can reach the upper layers of Saturn's atmosphere. As it moves deeper into the denser layers of the atmosphere, atmospheric drag generates extreme heat, causing the spacecraft's systems to fail quickly. Due to atmospheric friction, the materials of the spacecraft would begin to disintegrate. If the astronaut wore a spacesuit, it would not withstand temperatures above 200 degrees Celsius. The heat seals would break, and the extreme heat would begin to affect the body. If the spacecraft continues to descend, it will encounter regions with higher pressures than Earth's. Without protection, the pressure would crush the astronaut almost immediately, compressing his chest and organs and perishing in an endless fall. The extreme pressures would have crushed and disintegrated the body just a few minutes after entering Saturn. If the spacecraft continues to descend, temperatures near Saturn's core, thousands of degrees Celsius, will vaporize any debris. It's an ending worthy of an adventurer. Uranus. The two most distant planets in the solar system have interesting surprises in store for us. Uranus is also a gaseous planet, so we cannot land directly on its surface, but descend in a space balloon designed to float on the planet's dense clouds. However, descending into Uranus's clouds would not be pleasant. 2% of this planet's atmosphere is methane, a gas extremely toxic to humans. As we descend, the slightest failure in the pressurization system would lead to poisoning in the crew. We should consider that the clouds on Uranus move at up to 560 miles per hour or 900 kilometers per hour, so gusts of wind could easily break or crack the spacecraft. If this happens, the last barrier will be the astronaut's spacesuit, but he will surely meet the same fate. Without a support spacecraft, the astronaut would only fall into what appears to be an endless fall for thousands of miles. As you descend into the clouds, the pressure slowly increases. But if he survives and reaches the deeper clouds, approximately 6,300 miles or 10,000 kilometers below the outermost clouds, you can witness an unparalleled spectacle, a shower of diamonds. At this depth, atmospheric pressure and temperatures are so intense that the carbon in the methane is compressed and turned into diamonds that form in freefall. Yes, as you heard, it rains diamonds on Uranus. But let's remember that carbon is one of the main components of the human body. About 18% of our body comprises this material. This means that if we survive the fall of 6,300 miles or 10,000 kilometers and reach the diamond rain zone, our body would also become a substantial human-sized diamond. Very brilliant way to die, don't you think? Neptune. Finally, we have Neptune, the planet farthest from the Sun and the coldest. A visit to this planet would require a spacecraft with a significant thermal energy source. The temperatures on this planet are minus 360 degrees Fahrenheit or minus 218 degrees Celsius. And at these temperatures, a spacecraft's welds and materials would be at risk of breaking. At first glance, Neptune resembles Uranus. Both planets are composed of similar materials and proportions and are even very similar in size. However, Neptune stands out for something not found on any other planet: the fastest wind gusts in the entire solar system. Wind gusts have been reported on Neptune reaching speeds of up to 1,300 miles per hour or 2,100 kilometers per hour. This means that the wind on Neptune has supersonic speeds as it moves faster than sound. These high-speed winds would cause a spacecraft to lose control with no other choice. Neptune also has rotating vortices like those of Jupiter. One of them was the Great White Spot of Neptune. This spot was a massive rotating storm in the upper atmosphere, with winds reaching up to 1,500 miles per hour, or 2,414 kilometers per hour. If the spaceship were caught inside a vortex like this, the supersonic wind gusts would tear the ship to pieces long before it managed to get out. This would leave any astronaut exposed to Neptune's atmosphere with toxic gases, extremely low temperatures, and crushing pressure. Any living thing would die in an instant. Is this how we get to the end of this journey? What? Is Pluto missing? Well, if you'd like to know what it would be like to die on Pluto, it would be very similar to what we saw on Ceres, a cold, very cold death. On Pluto, the predominant element is nitrogen. When you set foot on its surface, this element would break the suit's seams as if it were made of paper. This would expose us to the freezing temperatures of the surface of this dwarf planet, which is about minus 387 degrees Fahrenheit or minus 232 degrees Celsius. Exposure to these low temperatures would turn every molecule in our body into an ice crystal. Without any chance to move or try to escape, we would be frozen for eternity, like statues. Now we want to know your opinion. Which of the scenarios shown did you find the most interesting? Let us know in the comments.